All right. Good morning, C. Grover. Let me do this so I can actually see the names. Let me grab my headphones. BRB, 1 second. Okay. Morning, Bear. All right. Thank you for bearing with me this morning, as I am a few minutes late, and as you may be able to see, the stream is a bit different. In this case, the thing that's different is the chat is not transparent. I tried to have it in the old scenes. Okay, I don't want to hear myself. Thank you. In the old scenes, the chat had a little bit of transparency so that you could see what's going on. For instance, down in the bottom right corner of my screen, down here, where it's covered up. So that leads me to the next place, which is that we have some setup to do because my computer, my hard drive specifically, died on me this week on Monday, and I've gotten a lot of stuff set back up, but not everything. In particular, I'm not set back up all the way for CircuitPython development yet. So I'm going to be doing some setup for that, and then we'll get back into the bitmap rotation stuff from last week, and then I will try, let me try OBS transparency filter. I don't know exactly how I did this before. Blind, how do I change? Right click, filters, color correction. See if we can do that real fast. Filters, color correction. Yeah, I never would have guessed color correction for transparency. Gamma, contrast, brightness, saturation, hue, shift, opacity. There we are. Okay. Can I get to a preview? There we go. Actually, no, I cannot get to a preview. Fair enough. Opacity, intuitive. Oh, it is previewing actually. Okay, so let's maybe chunk it down a bit further. All right, let's try that. If the chat's too hard to read, let me know, and I will change it a bit further. I don't know what it was set on before, so yeah, nothing like a hardware failure to force a clean environment. Yeah, ain't that the truth? That has been my week. But I will say, fortunately, all things considered, I got off relatively light. It could have been worse, basically. I'm not missing anything that was kind of like quote unquote mission critical. There's a few things I'm missing that I'm a bit bummed about that I should have done a better job of saving in a more secure place. But all things considered, yeah, relatively light. Let my bummed outness for the things I lost be the warning to everyone watching. If you are watching and you have any files you care about that are only saved in one spot, you should back them up somewhere different. Make a copy somewhere, sign up for Dropbox, do something. Just get them somewhere else. Learn from my pain this week. Okay. All right, bear with me one more minute here. I need to log into something here, which I do not know the password off the top of my head. Do they? Does your username change? Yeah. Okay. Okay. Twitch is like, you've never logged in before. Let me show you everything. Okay, thank you, Twitch. Very kind of you. Okay, I think we're finally more or less set back up for streaming. I don't know if I saw this last week. Truthfully, I don't think so. But thanks, Hug Report goes out to Boss Scans over on Twitch. Thanks, my friend over on Twitch. I don't know if you'll see this or not, but if you do happen to see this, thanks for the follow over on Twitch. Definitely appreciate it. Let me... guess that doesn't really... Oh, here we go. Okay. Probably haven't looked at your Discord profile since you changed usernames. Yeah, it was, this one was Twitch. Discord, I will say to their credit, they are, it's relatively easy to log into Discord because of the phone thing that they have. It's also a great place to update your configuration, readme, and credential. Yeah, so, yeah, I also took the opportunity to update to Ubuntu 24.04. I was on 22.04 or whatever the last LTS was, and I've been meaning to be updating to 24.04 truthfully any time. So I was like, let me just rip the Band-Aid and go ahead and jump to that as well, so that way I'm not like setting up my computer again now and then still going ahead and setting it up again in another couple of weeks or months or whenever I get around to it. So I also jumped to 2404, and so I'm solving all of the stuff that goes along with that, where stuff's not quite working how it was before, and things of that nature. The chat's probably a bit too much, isn't it? Well, I guess it just depends on what's on top of it. That's probably a bit too transparent. Anyway, I will mess with it. I'll try to mess with it offline. I don't want this to just be a me messing with OBS, but if it is like completely unbearable and someone's trying to read it, holler somewhere, ping me or something, and I'll fix it for now. But I'll try to power on for now, and then jack with it offline if it doesn't become a complete no deal breaker. All right, so yes, welcome. Thank you to everyone who's watching. For anybody who might be new, my name is Tim. I go by Foamy Guy on GitHub and Discord. This is a weekly live stream, which usually starts around 10 a.m. Central Time. I'm running a bit late this week, as we've been talking about. But typically 10 a.m. Central Time is when you'll find me here streaming about CircuitPython. If you don't know what CircuitPython is, you can learn more at the main website for the project right here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. When you run CircuitPython on these devices, they will typically plug into your computer with a USB cable. They'll show up like a thumb drive, and then you can edit some Python code files on that thumb drive. And then as soon as you save it, the tiny computer that's inside of here, the actual microcontroller, will recognize that file got saved, and it will read and execute the Python that is in that code file for you. And then the Python code itself is able to interface with any electronic peripherals that are hooked up to that microcontroller. So lots of these devices will have all these I/O pins along the side where you can plug in all sorts of other peripheral devices. Some of them, like the one that I will be messing with most today, come built in with some stuff. So this one is a PyPortal. It has this one's in a case as well. Is the Titano in a case as well in the picture? No, the Titano's just plain. Let's do that one. That's a little bit easier to see the microcontroller itself. So this one is still a microcontroller, but unlike the others, it doesn't necessarily have a whole lot of I/O pins, but what it does have is a bunch of stuff that is built in, a bunch of peripherals ready to go that are actually just attached to the device, ready for you to use, including a small-ish display, although this is the biggest one of the available PyPortal. So the display, compared to the other PyPortals is pretty big, but compared to like modern cell phones and stuff is on the smaller side. This is, I think, 3.25 maybe. Yeah, something right about there, in fact. Maybe 3.5 for the Titano one, this one. So it's got the screen built in. It has a touch overlay. It has, I think, an accelerometer, a couple other things. There's a built-in NeoPixel on the back. There are a couple of I/O pins in the form of these, what do they call those? JST, I think, cables there. The 3-pin and the 4-pin JST cables. But this device is more specialized for the screen. The idea here is you can draw whatever you want on the screen. It does also have a microcontroller which has access to Wi-Fi, so it's able to download information from the internet and then show it on the screen. That's like a pretty typical use case for this device. But taking a step back, these microcontrollers do come in all shapes and sizes. That's just the one that I'm messing with today. There are many, many, many different devices here. In fact, we can see 517 of these devices that support CircuitPython. So some have the built-in peripherals like we're talking about. Some specialize in being a very general thing with loads of I/O pins that let you hook up whatever you want. Others are made for other purposes. There's pretty much something for you no matter what your specific needs are, as long as they involve like electronics in some way, right? Like it's not going to help you, make your bed necessarily, unless you have some servos and stuff too. Let's see here. Okay. So setup, where I am starting is I have not done any of my PyCharm CircuitPython setup. Let me also say, as always, CircuitPython, it's an open source project. Anyone's allowed to use it on your own hardware. If you have one of these 517 devices, you're allowed to install CircuitPython and use it free of charge. You can use it however you want. It's an open source project. You can even port it to your device. So if you're a hardware designer or a hardware manufacturer and you make a device and you would like to add CircuitPython support to that device, that is totally free as well. You can totally do that. And all of that stuff is free to the end user and to the device manufacturers and everybody. And the way that ends up working is this company, Adafruit, hardware and software manufacturer based out of New York, currently in the process of moving a bit further away from their original place, but still in New York. They are paying the folks who work on CircuitPython. There's a team of folks who work on the project full-time who are paid by Adafruit to do so. There are some folks like me who are paid to work on it part-time by Adafruit, and that is all, of course, made possible by them. And if you want to help support CircuitPython and Adafruit, one of the easiest ways that you can do that is by just purchasing hardware from them over on their website, adafruit.com. They have the microcontroller devices themselves, like the PyPortal Titano that I'm using today. The one with the screen on it is an Adafruit device. They manufacture and design all sorts of devices like that. They also have little add-on peripherals. Like this is a little USB-C cable here that caught my eye, but they have all sorts of little doodads and peripherals, sensors, buttons, switches, glowy lights, RGBs, pretty much any kind of electronic little doodad that you can imagine. They've probably got a breakout that lets you connect that up with the microcontroller, and then if you want, program it with CircuitPython. So huge thanks to them as always. And then, now jumping into some setup stuff. So I need to get my PyCharm ready to go for CircuitPython development. And the place where that is documented is here, Essentials. No, is it? I think it's actually Welcome. Welcome to CircuitPython. We want Advanced, PyCharm, and I need to do some of this stuff. So I need to disable autosave. So, and this is all optional. When I say I need to, I don't, I guess, necessarily literally need to, but it is how I prefer to develop CircuitPython inside of PyCharm. I'm going to go ahead and make a project. I know this is saying to do that first. I guess I can do that first. Yeah, let me just do that first. Appearance, behavior, system settings, and then we want to do the autosave stuff. So that is settings, appearance, systems settings. What did it? Is that what it said? Yeah. Save. So we do not want to do that. We do not want to save like that. Okay. I never did come back and add. This is actually a good opportunity maybe to update this guide as well. There is actually one thing we could add to this guide, which is technically, so I'm going to apply this and then I'll show you what I'm talking about basically. So I turned off autosave. By default, PyCharm would autosave anytime I would like click to another file or click to run or alt tab, or pretty much anytime you do anything, it would autosave the files that you're working on. But for CircuitPython, we don't want that because by default, typically CircuitPython, it's going to run whenever you save. Although I do tend to disable auto reload as well, but I kind of have gotten used to the workflow of no autosave. So that's what that's talking about, disabling. But one thing that goes along with that is now when your thing is modified, you know, it would be ideal if there was some indicator that told you it was modified so that you would know that it's unsaved, basically. And in this case, the name turned blue because this is actually a Git repo, and therefore blue is the indicator that the Git version control has noticed some changes. So in this case, we actually do get an indicator. But in the case of the microcontroller devices, we're not going to be in a Git repo. We're not going to have the colors to rely on. But there is another thing, which is, I don't know, let's see exactly where it is. Let's try unsaved. Let's see what, nope, that doesn't get us anywhere. Modified? Editor tabs, mark modified. I think that might be it. Yeah, totally. So in a olden day, you would see this be an asterisk. Now we got all kinds of crazy, so it's just a dot instead of an asterisk, but that dot is indicating that this file is unsaved. If I save it with Control S right there, now there's no blue dot there. Okay, so there's my save indicator. So we should maybe add right here, but I'm not logged in. Right, okay, well, I will save editing this for another time as well. So I don't want to go track down my login, get this saved, but this is me reminding myself right now. We want to add right here, right below this picture, we want to add another screenshot and a little blurb of text that says about enabling the setting, which was called mark modified, which I don't think is the most clear name for it, but I did find it. This is also a good time to snapshot any configuration files and directories. Yeah, totally true. And I am also going to take this opportunity to set up a little bit differently than I was before, because here it says creating a project on the computer's file system, which I am going to do, but I'm actually going to do it in a different place than I had it before. In the place I had it before, it was kind of like my repos workspace, where a lot of the stuff in there was repos that were pushed into version control. But this particular directory, device workspace, which is the name I chose for it, this one was not pushed into version control. So my device workspace folder, unfortunately, is one of the things that is gone from my old drive. And what I'm going to do this time around is actually make that in Dropbox so that that's always being synced with Dropbox. Do I have a Dropbox CircuitPython? I do. Yeah, I think I'm going to just put that here. We're going to go device workspace here, home. So now if this were to ever happen to me again, my device workspace will not be lost because it will be in my Dropbox. Yeah, I guess I'll just go ahead and let it use a VM. So one of the things that came along with updating to Ubuntu 24.04 was Python 3.12, which there were changes in the way that the base interpreter works or whatever, so now you're kind of like forced more into virtual environments. One of the things I had thought about doing was making like a base virtual environment inside my home directory and then using that for the bulk of stuff. But so far I've actually been just letting it create ones per project. I'll see how long I end up keep going on that. I know that's kind of the best practice, but I do truthfully prefer, I think, one sort of big interpreter that has all the common stuff I use right now. Some projects that I do are more complex than others, and they're very dependent on specific versions. And obviously, in that situation, a virtual environment comes in super duper handy. But a lot of the times, I just want the same versions for all my projects. That way, everything is the same. Typically, that's the newest version. Use one per project, but symlink requirements. File requirements, using one per project, but symlink the requirements. Not sure I understand. Oh, like maybe I'm not sure if I understand. You'd have one base one, and then you would still have one per project, but instead of it being like a real one per project, it symlinks the libraries back out to the base one or something. Often have a baseline pip file and then a reference per project using one VM. I gotcha. Pip file. I've never actually used a pip file. Is that one different than requirements? I do have requirements in a lot of my stuff. Okay, so this is created. We want to do what it says here, which is going to be adding the content root because we want to be able to see the microcontrollers show up in here. File, new project. I did that. Create, file, settings. Project structure. I'm pretty sure there's a different place you can do this from, but okay. Go, we would like to add a content root. And for me on Linux, that's going to be /media/timc. Because that's where my USB drives spawn or get mounted. So then if I plug in a device, which I don't currently have one plugged in, but I'm about to. Make this one bigger so that I stop confusing myself with that. Pip file equals pipenv being deprecated, rendered unnecessary in 3.11 and beyond, if I remember correctly. Oh, I gotcha. Carefully feed this wire through so as hopefully not to just accidentally swipe everything off of my desk here. Okay, boom, CircuitPy. First thing I'm going to do, back it up. Don't open that. Okay. Okay, a couple more setup things we want to do. Let's keep doing what this says. We got our content root. Okay. Stubs, let's do that. Yep. Especially, I guess, for an environment. That's one of the good things is we can have our stubs in this environment, pip install CircuitPython stubs. I don't think I have circup yet. I know I'm going to want that. That's not on the page, but we could run that. CircuitPython setboard. So there's actually this now. But my portal, I want PyPortal Titano, but I'm not sure if it's, okay, yeah, I wasn't sure the exact name. Libraries will do as we come across them. Serial, so I don't have TO yet. I would like to get TO. Dial out group. I wonder if I'll have to do dial out group. Is there no TO on here? Okay, it does mention it, but it doesn't have anything about getting it. It might be nice to have the installation of that somewhere. TO. I don't remember. Is that an apt or? So I will say, like, one of the things that I do find a little bit frustrating about Linux is how many different ways there are to install everything. It's like, is it, did you install it with apt or snap or flatpak, or did you go to their website and download a deb file, or did you go to their website and download and it was just an executable and you run it? Or did you go to their website and download it? It was an app image. There's like, I get overwhelmed sometimes with like a million different ways to install a million different things, and then trying to figure out like, okay, now that it's installed from whatever one of those methods, like where is its configuration file, or where is its like data directory? Which I should say configuration. I guess it should be an etc. Hopefully, you would hope, but okay. What am I actually trying to do here? We're trying to get TO. So is that an apt, sudo apt in, let's just do a search on TO, and I do want exact, so I'm going to do the old up caret $. All right, it is that sudo apt install TO, so let's do that. One thing that is not listed on this page, but I know that I am also going to want is the GH CLI, the GitHub CLI, which I think I've never even heard of WinGit. Oh, that's Windows, okay. Debian and RPM, so there should be GH CLI. Another tidbit you could try is to save your shell history once you're happy. Oh, that'd be interesting. That would be a smart way to do it. What I have been doing is I have a file. Well, I don't want to open it up because I have some other files that I don't necessarily want to open, or that I don't necessarily want to show. And one thing I have noticed about Ubuntu 24.04, the text editor, the default one that's built in, remembers your tabs now. I don't know if it was a setting before and I just turned it off or what, but the old one did not remember the tabs you had open. The new one does. So I got to be careful about opening it. But anyway, all that is to say, I have a file in there, a text file. It's not the log of my terminal, but it is handwritten notes about like what I installed from where and all that stuff. I guess I should add this stuff to it, so maybe I will. Let me. I'm pretty sure I opened a blank one. Or yeah, that's fine. We can do that. I have a bunch of notes like this of what I have done and where I got it from, and configurations I've done on it. Is there anything else on here? So we should have TIO now. Let's see if TIO works. One thing that I would like is I don't want to be here. I don't know why this is where the terminal is spawning. Let me just close these. That seems like a more reasonable place to be. I wonder if I could make a link. It doesn't matter really. It's fine. Okay, so TIO. Nope. Okay, so that's not working. I'm guessing. Oh, in fact, it says right there, permission denied. I'm pretty sure I need to add myself to dial out. Which is probably. Actually, does not say anything here. I think is that user mod -G? No. Sudo add user username dial out. Sudo add user username dial out. I think you need to start a new one, but I'm not sure, and I'm just going to do it anyway. Although now we go to a new spot. I wonder if I can set that somewhere. The location where this will start in by default. Probably, but I don't know where. It still says permission denied, actually. So, actually, I think I might need to, like, completely log out and back in. I don't really want to do that. But I do want to be able to see the output. That seems a little dicey, but maybe would just work, right? Right now, that says it's owned by root and it's in the dial out group. Is there a way I could just refresh it? Okay. That's probably what we want. So we can just change to ourselves. So that put me at home. I'm just going to get out of there. Whoops. Nice. Cool. Yeah, let's upvote that. Thank you, kind friend. What? Oh, I already did. Whoops. Okay. And luckily that thing said it was locked in, so it didn't undo my vote, which is nice. Now dealing with shells and how they respond. Logging out reloads the terminal sessions. That's what SU does also. I gotcha. Gotcha. And then I think the deal will be like, once I do actually like reboot or relog in, from that point on, I'll never have to do that SU user trick again. That's just like right now I did that so that I can get the new shell or whatever. The shell under its new group. Is there anything else I want to do right now, or are we ready to actually jump into code? I think got TO. I'm not really using any libraries with this. Image load, I guess we could get image load. Sure, why not? Let's get image load. Actually, this is a different thing. Is it? It is, but has a random other thing inside of it, which is weird. Yeah, that's left over from something else. We do have image load, so let's get that. I could do it with pip, but I'm going to do it this way. Oh. Alright, well, apparently I'm not going to do it that way. Let's do it with pip. I'm surprised that clicking this, like, because I spawned a new one. I'm surprised that that new one wasn't in the right group or whatever. But that must be a thing to do with PyCharm, how it spawns this shell. It must be not technically, like, starting a new one per se, I guess. Git configuration, since that will require readjusting your config file. I think that I am set on Git, but I'm not positive. But I have done some, and I don't know actually for sure about GitHub. But I do think I'll do that offline so that I don't accidentally have any whoopsies. And so that I'm not just spending more time staring at stuff off screen. Pip install Adafruit, CircuitPython. Is it just image load, one word, I think? Oh, okay, so that just failed. Excuse me, what? Building wheel? What is that? Is that a thing? So it's... Connection manager? I don't have a GCC. What is this though? Like, why do I need GCC just to install a library? That seems weird. I don't know about that. Did it install anyway? Maybe, no, it's still red. None of that stuff installed. Guess it doesn't count until it all finishes. So is that a thing that Blinka depends on? Like, what is that sys thing? Need Python build environment? Why though? That doesn't make sense to me. Like I feel like I should be able to install image load, like a CircuitPython library. Not sure why it would need to build something with GCC. Like really literally all I need to do is it should just download the Python code. This one doesn't even have any requirements listed here. Requirements. Oh, there you go. Sys v whatever. Yeah, that's right there. Where the actual setup requires. Install requires. I almost think we should consider having, and I have no idea if packaging works this way, but I almost think we should have two like ways to install a library. Like one way would be if you're on a Raspberry Pi or intending to use Blinka to like literally use that library on the device you're installing it on, versus the second way, which is you're just installing that library in order to get information for your IDE. So you don't need, like, frankly, you wouldn't even need Blinka at all. You wouldn't need any of this stuff. You could just get the library by itself. But I have no idea with pip if that's like is there any way to do that? Maybe we need optional requires. Because right now, so I'm assuming if we were to go over to image load, it's gonna say that it requires Blinka, which then is gonna mean that we got to get Blinka and everything that Blinka requires. But the truth is, it only really requires Blinka if you're trying to like use it, like on a Raspberry Pi, for instance. If you just want it installed, you shouldn't need that, I think. Sysv isn't everything. It's a Linux binary, which CPython is, and the core of CircuitPython most likely is. That's what wheel is supposed to solve. Oh, okay. I'll have to look into wheel. I've seen wheel pop up, and I see it go by when you install something, but I don't know the actual, like, anything about it or what it does. Okay, well, I should solve this, I guess, because I'm gonna need to be able to do this stuff eventually, so... What is my actual root problem here? I mean, I think this is the root problem, right? Basically just that I don't have GCC. This is what I was imagining the solution being, which I think once I get to building CircuitPython, I'm going to need this anyway, so I think I'm going to install that. Is it essentials? Just essential. I'm going to do a search first. Oh. It's already installed. Alright. I guess we'll do the dev then. It just feels very bizarre to me that I would need this for, because this is for like if you want to develop Python, right? Like if I wanted to like add something to CPython, like submit a PR or build CPython, isn't this what I would need to do it? How's it going over in Twitch? Good morning, bro. Thanks, Rayun Evo. Thanks for tuning in, my friend. Let's see, I'm here in the battle writing malware in a C2 server. Oh, well, don't do anything illegal or unethical, please. But hopefully you're learning and not doing anything bad. I want to continue, yes. Okay, does this now... I don't know if I would need to, like, do the whole shell thing again, or... Nope, looks like we're good that time. Cool. Yeah, there we go. Now we have image load here. That's going to show up and tell us all the stuff we can do from that. Let me save that. Is there anything else we need now, or are we ready to just jump in? So I think I'm pretty much ready to jump in. I am gonna get the camera going here. Nope. All right. So, last week's stream, back in simpler times when we still had our hard drive. What I was working on was rotating bitmaps using this technique of 3 shear operations. And this is a technique that was utilized more in the past when we did not have as powerful GPUs, is the way that I understand it. And one of the nice things about this particular technique for rotating is the way that every single pixel that's in the input image will be represented as a single pixel in the output image. There will never be a situation where 1 pixel from the input image becomes 2 pixels from the output, or conversely gets like rounded out and becomes 0 pixels in the output. Webcam? Did the camera mess up? Nope. Okay. That was the old John Cena camera test there. So it's a really nice technique if you are using like relatively low resolution images. And particularly, like, especially if you're using images where you have like single pixels that are important. The example given was Mario, which I still have my copy of, thankfully. Be pretty sad if I lost Mario here, but he's here. So in Mario has got these two golden buttons on his suspenders. And those two golden buttons are kind of important, right? Because without them, it's a little bit like difficult to tell that Mario has his suspenders on. With other methodologies for rotating, it's possible for those single pixel buttons to either get rounded up and become 2 pixels or get rounded down and become 0 pixels. Neither of which we really want. But with this rotation, this 3 shear rotation here, that is no longer a problem because, like I said before, every single individual pixel in the input will get represented with exactly 1 pixel in the output. So the shear method allows you to do lossless rotations. Yes, with a caveat, I'll say. It is lossless in that you will not lose any pixels. You'll never lose or gain any pixels. You'll always be... you'll always have the exact same number of pixels you started with. They'll be in a slightly different shape, like the rect of your thing will be a bit different. And there'll be more transparencies in the case of how I'm doing it, at least. That's not to say that your image may not get distorted. There are going to be like some pictures are going to look better at arbitrary, you know, if you just rotate it by 10 degrees or whatever, and it's a really small image with single pixel stuff, it's, you know, likely to look a little pixelated and messed up when it's rotated at just any arbitrary angle. But in terms of like the technical, you know, will you have lost any pixels? You won't. You'll have the exact same number of pixels. And it's actually pretty good, honestly. Like, so, I think there are going to be some input images that it's better with than others. But the ones I've seen so far, it's actually relatively good. Now, that being said, obviously, it's not working properly. So where I'm at now, I've got this image, which Hug Reports goes out to DJ Devon for this one. This one actually makes it really easy to see what's going on in the current attempt of the code, which is that basically this right side over here is still messed up. I have a guess, which is that on our on our second, my guess is that on our second shear, which is a vertical shear, we are not, like, I'm probably starting left to right, operating on columns, and my guess is that we are missing 4 columns. We're stopping 4 iterations too early. Most likely because of the fact that we added a couple of pixels to the size of our image in order to account for the fact that we are shearing, you know, horizontally, the top half one way, the bottom half the other way, which means we need a slightly bigger bitmap in order to actually fit those pixels in. Now, you know, we're not gaining any visible pixels. All the extra pixels are transparent. We just need that extra space in order to scoot the top, you know, over by, let's say, 3 pixels and the bottom over the other way by 3 pixels, for instance. And then we have to do the same thing in the vertical because our second shear is a vertical shear and it's the same thing. We're going to be scooching, you know, columns in the left half up or down by a certain number of pixels. And then on the right half, we'll be scooching them in the opposite direction. For anybody, I will say, let me also, for anybody who didn't see the last stream, stand up maths, rotate. This is where this concept came from into my world, at least. This person did not invent this concept, but this person made a YouTube video about it that was the place where I originally learned about this, learned how it works, what it does, why it's helpful for small images and stuff like that. And then I'll say also hug report to Deshipu, which is who shared this video with me. So check out that video if you're interested in the math behind it or the theory, or like even he goes into a proof about why it works, which is not a level of it that I necessarily care about, but it is interesting nonetheless. And it does also go over the math as well as give a couple examples, which I was using pretty heavily when we were working on this before, and I may get back to. Okay, so diving into the actual problem, I'm guessing that the problem almost certainly is with our shear number 2. Well, so this is the second horizontal shear, which is actually the third total shear. So we do 3 shears total. First one is horizontal, second one is vertical, third one is horizontal. We got 1 vertical sandwiched in between 2 horizontals. I'm just going to comment out the third shear, the second horizontal one, so that we're going to do our first one, which is horizontal, our second one, which is vertical, and then we're going to look at the result and see how it looks. Okay, that's just going to pop up anytime I use that. Okay, that's interesting. Oh, it's asking me what to put in the other half? Okay. Yeah. Okay, so that's already messed up. So let me actually turn off the first shear, the second shear too. Let me turn off the vertical shear so that we can try to validate whether it looks correct after the first shear, which is just horizontal. Yeah, that looks good. That I think is correct. And yeah, I think we must be not, on our second shear, I must have not accounted for the extra size. The extra size of the bitmap. Yeah, see, this is going for column index in range bitmap.width, bmp.width, but that's the original bitmap. We actually need to be looping over the columns in the current bitmap we're operating on, which is the one that has had the first shear applied to it, which in our case made it a total of 4 pixels bigger. 2 pixels on the right side and 2 pixels on the left side. And then this center slice there, that one, that slice in the middle, that has the width of the original image. But the thing is, I guess that should be fine. I think that should be fine. So I was thinking, like, is that going to mess it up if we just change it? Because then we're going to be having bigger shear amounts potentially. Because the shear amount, which you'll see if you do watch that video, the shear amount, the how far to shift a particular row or column is based on how far away from the center it is. The further away from the center, the more it gets sheared. Camera just died. But I think that should be fine. Like, it is going to shear more than it did on the first shear. That part's true, but I think that that's okay. And so we are operating on what at this point? We are operating on, so the output bitmap. So in order to apply this shear, we are taking a slice from the output bitmap, putting it into the vertical slice buffer. Then we are erasing the slice that we took so that it's gone out of the output bitmap. It's no longer there. It just gets filled in with transparency in this case. Then we are blitting our vertical slice buffer, which has that column that we took. We're putting that into the output bitmap, but we're offsetting it by x, y, which are variables that ultimately contain the shear amount. I don't know if this x is going to be right. Part of my brain thinks that's going to be wrong. So, and then the other problem is I pre-calculated V midway. Which is going to be wrong now because we are doing output width instead of just V and P width. So this needs to be recalculated. I'm just going to do output bitmap width over 2, which is how it was calculated the first time. Yeah, okay. Minus call index. Center to call index? Oh, okay, I know what this is. This is basically offsetting our index so that the left half is negative and the right half is positive. Instead of the index being 0 to 1 minus length, or length minus 1, I mean, this offsets it so that the center, the middle column will be at centered column index 0. Okay, which is important because, like I was saying about the shear amount's based on so then the next thing that I wonder, this is using V multiplier. Do I need to recalculate the V multiplier? No, because that's just the sine of the angle. Okay. Okay, so I think we can leave that the same then. All right, let's see what it does. I don't know. I wish I could just go back to this, but it came undone for a second there. I guess it did the second time? Oh, it crashed. Okay, y must be between 0 and 24. So I already have a bunch of these printouts here. So we got a -2 on y. Which is definitely wrong. Okay. So one of the things I was doing to try to debug this, to try to just like visually understand what's happening, like honestly, there's a bit too much pixel math and stuff going on here for me to actually keep a clear following of it in my head. But what I was doing was using these things, which will draw visually what it's like working on at that time. So let me comment out this. Let's uncomment these. And let me just go and add like a time.sleep 0.5 so that this will go a lot slower. I just have to do that twice now. Now it fails on the first one though, so we never even make it. Okay. I'll tell you what. I got a BRB. I'm gonna run to the restroom real fast and then I'll be right back. I think we need to just offset our Y. Need to offset our Y somehow. Yeah, BRB though. Okay, we are back. So then this is actually failing on '83. Let me try not doing that. I think that's the white dot. So this draws a red line and a white dot, which represent the line that it's going to cut, the column that it's going to cut in this case, because we're vertical. That's what the red represents. And then the white dot is the coordinates where it's going to paste it. I don't really know why. I don't really know why we didn't see anything. Why not move your source? Why not move your source image down a few pixels, then put markers on the edges of where the shear will happen, then put your dots below the source image. I mean, I could say the most specific reason why I'm not doing it that way is I don't really understand what you mean. Frankly, like, I'm super visual with this. If you could draw what you mean, and I could look at it, then I could understand it, but I'm not really understanding what you mean all the way. And then the secondary answer of why did I do it this way or not any other way is just because this was the way that it came to mind, and it's not even working correctly, so I don't consider it having me done it this way yet. It's just how I started writing it and the direction I currently am going, but I'm not like dead set in this way. It just happens to be how it came out of my head. So basically the problem is that's out of bounds, and in order to resolve that, we need to have a min, I guess. So the thing is, I really thought that this was a thing that actually was solved somewhere already. Yeah. Yeah. This is basically what we need. So if the y value is negative, which basically means that we're taking a slice and then we're trying to paste it in a place that is technically outside the bounds. So really what we want to do is like, paste it there, but then only show the part that would be in bounds. So a couple of our pixels are going out of bounds. In this case, we know those couple of pixels that are going out of bounds, we know they're going to be transparent as well. So we know we're not losing anything. It's just that Bitmap Tools raises an error when we point it to a location that's out of bounds in this way. So what we can do to solve it is basically, if the y is going to be negative, we are going to cheat a little bit instead, and we're going to say that the y1 is going to be the absolute value of y or should it just be 0? Oh, no. Okay, I get it. So that's so we shift the box that we're gonna take, we shift it down by the amount of negative that y is, and then what we do is we say y is actually gonna be 0. So we grab a box that's x number, I shouldn't use x, that's n number of pixels shorter, where n is the amount of negative that y is, and then we actually set y to 0. So we have a smaller box, we move it to where y is on 0. And then the pixels we lost at the top by cutting this out, we know those are transparent. Oh, I don't like that. I wish the first one would go back to the side. So, out of range of target, it says. Let me print after I do that, first of all. Gotta head out, catch the remainder in the VOD. Thanks. Yeah, take it easy, Seagrover. Hope you have a nice day. Let's see, this puts you... Okay, so let me see here. So we have... Then put your dots. So we have basically our image... And so the X shows where the shear will happen. X shows where the shear, or use 1 or 2 to be the shear step. Okay, did you mean in terms of just showing a visual? Like visually a way to see it? Or do you mean like as the algorithm it's using to actually shear it? I'm still not... I mean, basically, it boils down to I'm still not necessarily really understanding all the way. Sorry, I know it could be potentially frustrating when someone's not really understanding what you're saying, but Let's see. So why does this should be... So this says y is -2, but it's not doing this. Why is it not doing this? Print y is negative? Okay, now it did. Maybe I didn't restart it before? I don't know. Just to be able to print. I gotcha. Oh, to be able to print in the terminal. I see. I see what you're saying. Like an ASCII way to view it. Yeah, I don't have a necessarily a specific reason for not doing it, but basically I would say the closest thing I have to a reason is just in my brain, the visuals that I get with this red and white are just real clear and easy for me to understand once they actually get drawn. Okay, so for one thing, like almost certainly X is wrong here because we are on the first column index. We should not be changing X. X should be 0. So that's wrong. Okay, so 0, 6. Six sounds very large. I'm not necessarily expecting 6. It's all good. I'm trying to ask questions to help you focus. I gotcha. I appreciate it. Trying to use bitmaps to debug bitmaps. My rule is never use the thing you're working with to debug the thing you're working with. It's a good rule. Okay. We're not doing 6. I don't know. 6. Oh, -6. That's the I don't know if that's wrong or right, I guess. I really got to get it to draw to see it. I do think what you're saying is probably true, but for whatever reason, my brain is stuck on really wanting to see the pixels. What is out of range? I mean, the only value that's really big anymore is this. And I guess that should probably not be... So I don't know if it's inclusive or exclusive. But I'm guessing maybe that's not... I'm guessing that's not... That maybe the thing... So it started... I know we started on 16 by 16. I know that we added 2. So our new size is 20 by 20. Because we have 2 extra pixels on all 4 sides. Is that true? Let me make sure that's true. I am printing this one. No, I'm on 24 by 24. Okay, yeah. I'm on 24 by 24 because actually I need to shear twice, right? I'm going to be shearing twice horizontal. Only shearing once vertical, but the way the math works out, the vertical shear is twice as big as the horizontal shears, basically, roughly. So 6 maybe does make sense, actually. I was expecting 2, but the reason I was expecting 2 is because I was stuck on horizontal shear mode, which is going to end up being half the size. So obviously 2 doubled is actually 4, not 6. But my guess is the fact that our thing is wider by those extra pixels means that our shear amount's going to be a little bit bigger. So going up to 3 seems plausible, and then doubling because it's vertical does actually totally make sense. So 6 is probably right. Half of the difference of the vertical total. Yeah, basically the horizontal ends up being, the horizontal shear amounts end up being about half of the size of the vertical ones. Technically, it's all controlled by the trig, but because, I guess, well, yeah, which makes sense, I guess, because angle is over 2 right there, so the V multiplier ends up being typically about twice as big. Now, it'll depend on the angle, but for the exact number, I think, although I'm not really that good at geometry, so whatever I think about it could definitely just not be true. Okay. But my next question then is, so we have a shear amount of 6, of -6. But I don't see why that's out of bounds. So in my head, I do see that I don't think the math is right, but I do also think it fits within the bounds. So why do we get this? Because we're printing all of these. X and Y are both 0. Y1 is, no, X1 is 0. Y1 is 6. So 0, 6. Is it because... No, so we go over by 1. And we go down to 20. So the rectangle between 6 and 20 that's 1 wide. Out of range of target. Well, okay, hold on, though, because we are dying... Let me run this again. We're dying on line 90. We're dying on line 90, which is actually using... just... X and Y... We want part of that, but not all of it. Okay, I know what the problem is. I don't have white anymore. I changed bitmaps, basically, is what it boils down to. This 17 is actually 17 talking about the index of white in the picture that I was using before. Is not the picture that I'm using now. So it's not talking about out of the range geometrically, the XY range. It's talking about the amount of colors. 17. We have less than 17 colors. I don't have GIMP yet. Okay. The truth is I want a white pixel so that I can have white in the color map. So I'm gonna draw one pencil, one. Just gonna why is the opacity not working? Okay. So I was using red before, but there was no red in the picture. Now there is. I'm gonna get rid of the red and make this red be like a pink or purplish. Then make an actual red single pixel. Now go mode indexed. We have red and white, and I'm gonna just make them 0 and 1. And actually, I think one more thing I want to do is this pink is maybe just a tad too close. I want a little bit more distinction, I think. Which pink is this? Is this full pink or? Let's do that. Okay. Actually, I'm going to save this. But I'm actually going to come back now and undo these. So that those are not part of the picture, but we keep their colors in the color map so that we can use them. Now I'm going to save it again. And then take that and put it back on the device. Let that one override. Give myself some room to see stuff here. And then, so white is 0 and red is 1. Okay. Now, next thing I'm going to do, if call index equals 0, only do the first column. So let's just get a look at the first iteration through. Okay, and now actually one more problem we have is there is code in here that's doing set transparent. Make transparent. We don't want that. Okay. When I said we don't want that, it turns out I was not entirely necessarily accurate with that. Boy, I really wish I could just add a color to the map. Yeah, I really, really, really wish I could just add one right here. Why is that not working? Because the problem is, we're going to go back to RGB. I'm going to save 2 copies this time. It's not really going to help me, though. Yeah, I don't know. Okay, 1 gray pixel, 1 white pixel, 1 red pixel. Back to mode indexed. So I'm going to do gray on 0. We are going to make it transparent because I do actually want transparent, it turns out. Then white, then red. And then get rid of these. Update that. Turn this back on. Then the colors are 1 and 2. There we go. Okay. So a few things about this that are interesting. We're actually still outside the visible area of the shape, which does make sense because we made our image actually 4 pixels bigger. So we don't really need the first 2 iterations or the last 2 iterations, actually. We can get rid of them. Fun of mostly being colorblind is I never do this kind of work. Nice. Yeah, GIMP is really, like, nice for what it is. It's a really nice editing thing. Does pretty much everything I want. But there are some things where it is, like, the workflow to do it is a bit cumbersome, truthfully. But I also think it's, like, completely scriptable. Like, I probably could be figuring out the command line options to do the things I want, potentially, so. Okay, another thing that is kind of interesting about this is the blue. If you look at the blue square, we shifted the top of the blue, but not the bottom. And just off the top of the head, that would not seem to make sense because basically what I was talking about before, we shifted the top half and the bottom half, and we should be shifting them by the same amount, but there is one caveat to that, which is when we have an image that is an even number of pixels, this is a 16 by 16 image, the center is offset, right? The center is a line between 2 pixels, not an actual pixel, which means that we can't really use the center, and basically what it ended up doing is going one further down, which means that the shift, depending on the size, technically could end up being a little bit more on one side or the other. Or I don't think it could mean that it would be more, but it can mean that this kind of thing can happen where your image, like, you might expect it on the surface to shift by the same amount, but because the center is actually offset by a pixel and we have that rounding error, our center box there is not where we might expect, but that's okay. So I do think we want to cut the first 2 and the last 2 off of this. So right now we're looping for column index, in range, output, bitmap, width. I think but we don't know it's going to be 2. Well, we do, because it's the first column, it's the first row shear amount, which in my case is 2. Well, first call shear amount? No. We care about the rows because that's going to be how far outside we have to work with, basically. So the first row shear amount, which was getting added earlier and I took it out, but it actually does need to be there. And here, and here. But we don't need to loop over the entire width of the output image, but we also don't want to loop over the width of the input image, which is what we were doing before. We had bmp.width here. Really what we want is the output image width minus the first row shear amount, basically. So that should skip the first two and the last two. There we go. Okay, so we're taking... So if we were to uncomment the rest of our code, the line that got colored red, we're going to cut that line, and then we are going to paste it to where its top pixel right there is actually all the way up here. We're basically shifting it up by that amount. And I will let it do the first one. So this time it will actually do the first shear instead of just drawing it in. Okay, so it has pulled that pink right there quite a ways up. Let me try putting this back in and see if we can actually like watch it go row by row, or... Oh, no, because we still have the if statement. Okay, so I had this problem before too. It's not drawing now. I do not understand why that's not drawing, but also I gotta run to the restroom again, so BRB again. That looks pretty good though. I have a theory, which is that we probably did not set the thing on the display until after the end. Or, yeah, that's the next guess, is that I haven't done a refresh or whatever, and I don't have auto refresh on, basically. So let's see, where do I... Okay, yeah, so the thing is I don't add the shear rotated tile grid to main group until the very end, which is after the shear. Okay, but we kind of have a chicken and egg problem here, because shear rotated bitmap is the result of shear rotate. Yeah, basically I'm getting bit by what you were trying to talk me out of earlier, or talk me into the better way to do it, which is debugging with a different medium. Because basically my problem, I'm not going to be able to visually see this because it doesn't exist until after it exists, basically. I could like try to make a temporary one or something. Yeah. So really, in order to like be able to see this visually, we'd have to like existing bitmap equals. We need to do something like this. Then we would need to create the shear rotated bitmap first. Then we would need to pass it into here. And we would also need to create its tile grid first. And then we would want to have both the bitmap and the tile grid existing. And we would want to have the tile grid already added to the main group before we call shear rotate. And the only way we could do that is if we were to accept an existing bitmap, which currently shear rotate does not do. It creates a new bitmap inside of here. I guess one thing I could do is like, we could just add it right away inside of there. Except the actually, there's not really any except that's, I don't think. Let me just comment this out and copy it. And then right here, after we create output bitmap, but before we've done anything else to it, we'll just paste that. We'll create the tile grid, same way as we were. We have access to the palette. We have access. This is actually called this now, though. Same thing with these. We just do both of those. And then we can just... Yeah, it's already doing main group right there. So we just let that happen. Okay, we might be out of order a little bit. Something might not exist just yet, I'm not sure, but let's see. Nice. So there's our vertical shear in action. Got worried there in the middle, but that's actually, it makes sense because the middle doesn't move. Whew. You'll need to cache each bitmap, get the largest possible size, then set the tile group to that size. Let the flow through cache, yeah. That would be one way, yeah, is if we pre-calculated the size. This way works out a little bit better. I'll probably I'll probably go back to doing this the other way, but this is helpful for during debugging for sure. Okay, I think that that is correct now. So before we had a very clear and obvious problem in the upper right-hand corner, and now it looks good to me. I don't have any other implementation of this where I could try to like compare it to that and make sure it's working, but it looks correct to me. We still have exactly 4 pixels in the center. We are shifted by 2 at this point, so our 2x2 square has become a a Tetris thing there. Our blue still goes all the way around. Now there are gaps, so there is like a gap here in the blue, but that gap is not caused by a missing pixel. That pixel is existing here or over here, or this one we ended up with 2 side by side there at this particular angle. We are still 1-to-1. And pretty pleasantly around the outside, we don't really have hardly any gaps. Like the only gap that sorta kinda exists is like right there. And again, that's not a missing pixel. I'm almost positive that's just a basically we have slightly more, because of the way geometry is, we have more kind of like distance. Basically, our distance is all chopped up into pixels and then rounded off, but we have like a longer line because of diagonals, I think. Okay, it looks right to me though. So let's go ahead and try and throw in our third shear. Let me also just take that. Let's do this. Let's say debug equals false. And then we'll do this right here, if debug. And let me, well, the sleep is down here though. Okay, let me put the sleep in the debug true as well. Only sleep if we debug. I'm gonna leave this for now. Technically, we could just get rid of this and we could bring all this stuff back to the left one tab, but in case I end up wanting to go column by column again, I'm gonna leave this here, and not even go column by column, but rather like do the first column, or maybe do the first 3 columns or something. That's really what this logic was doing before. The method also helps be able to see the before and after while calculating. Yeah, which helps, definitely is helping my brain get wrapped around it. Being able to see it live in the process like that. Okay, so we should be able to try this one now. So let's just turn that back on. And let's read through it just real fast. Make sure it's not doing anything crazy. So row index, output bitmap height. So that does make sense now because we have already vertically sheared, which means basically we are using up the entirety of our output bitmap height, depending on our input. If we had a bunch of transparency in our input, then maybe we wouldn't, but. So we want to go every row. We do recalculate the centered row index. We do already have this, so this one might just be good to go. It might just be I had the middle one messed up and that's it. So let's try this. I need to turn back. So I did debug defaults to false, but I have also uncommented, or I have also commented these things. So let's do that. There we go. And we are on, I don't even remember what angle I chose. And I definitely don't know radians to angles off the top of my head. Radians 2 degrees. $30. Yeah, I'd say that looks 30 degrees. So we went from a horizontal there, and we're now pointing down. I mean, to my eye, that looks like 30 degrees. About as good as you get, 30 degrees in pixelations. Let's try a couple more. I mean, one thing we could do if we wanted to be going real crazy with it is we could, like, rotate it a little bit and then draw it, and then rotate it a little bit and then draw it, and then rotate it a little bit and then draw it. I will say one thing about the way we've done it that that makes that a little bit hard, or at least let's say inefficient, is that we are always generating a new bitmap here. So like if we really wanted to be able to call shear rotate like multiple times on the same input image, so and to be clear, this is not shearing again the output. It's not that, because I do think it would get more and more distorted probably if you do that. But if we wanted to re-shear the input image, shear rotate at different degrees, it would be ideal if we could reuse the output bitmap. So maybe we should try existing BMP. I don't want to mess with it right now. We'd love to see if 2 rotates back to back to the original. I'll try it, but I think the answer is that it won't. I think that it will not be exact. Because there's still some kind of roundings going on, I'm pretty sure. Which could make it, well, and then for one thing also, the angles are not going to be exact. Well, I guess let's do it by radians. So let's say like positive 0.5 and then negative 0.5. Let's call this rotated back BMP. We'll shear, rotate, we'll try the... So another thing about this is it's going to get bigger again. If we rotate the output, if we rotate the one that's already rotated, it's going to keep getting bigger every time we rotate. So I will try it, but I guess what I would say is, as the author of the function, I recommend don't do it, basically. Although it'll be interesting to see if it works. How's it going, DJ Devin? You're using the color blocks? Yes. Hug reports to you. Thank you for this, and definitely it has helped. Definitely it has helped quite a bit. Yeah, I made it real clear. The problem that if you happen to go back and watch the VOD, you'll see towards the beginning the way that it was drawing before. My top right corner was kind of messed up, and this test image made it a lot easier to see visually what was messed up compared to the Blinka picture that I was using before. So yeah, huge thank you for that. All right, let me do 0.5 so that we don't have any we have less gnarliness here. Let me comment this. Let's just make sure a 0.5 draws and doesn't explode or do anything crazy. Okay, very good. There's a 0.5. So now we can make a rotated back. We can shear rotate that. We can 0.5 it. We can negative on that. I'm pretty sure that should work. Palette can stay the same. We need to make a new tile grid for it. So we'll call that the rotated back TG. Rotated back TG. So that's going to be this one. Palette's the same. Width, height, 1, 1. Tile width. We can do this. And this. And then what we'll do is we'll put this rotated back. We'll go down. So Y, let's just say... it's like 16 times 5. I'm just going to guess 100. No, that's too big, though, because we're scaled. Let's just do 20, and I think that'll work, maybe. I think maybe that'll work. So Y20, and then let's do X a little bit, like rotated back TGX, like 5, 4. So we're scaled up as well. So these pixels sound small, but they are going to be getting scaled by... I don't know, 3 or 4, or whatever we're scaled by. Okay, main group, append, rotated back. All right. I was not expecting it to work, but I was expecting it to be a little better than that. Maybe that's wrong? Is that not how that works? So I thought I handled, okay, let's comment this out. Let's try, let's level set a little bit. Let's try to validate some of my personal assumptions about this. If this is 0.1, that's going to be a very small angle, right? Yeah. And if it's negative 0.1, it's going to be the opposite small angle, right? Yeah. Yeah, I don't know. Basically, it's worse than I thought it would be. It seems, unless if I have a logic error here. So rotated back equals shear rotate. Oh, wrong thing. Here we go. This needs to be the shear rotated. So I do have a rotated bitmap and a rotated tile grid where I tested this with RotoZoom, which is a different way to rotate. Okay. Yeah. Okay, let me do 0.1 and negative 0.1. Let's do a smaller number first. I did negative both times. Actually, it came back together. I'm actually really surprised. Let's try 5. No, 5 is too much. So I think this is the result of rounding, basically. Because every arithmetic operation we take results in a float pretty much, and we end up truncating it. So we're doing like tan and sine is the trig stuff that we're doing. That's given us a gnarly float, and then we're taking that gnarly float and we're multiplying it by integers, which is giving us more floats, unless we get super duper lucky. And then we're truncating all of those floats back out to turn them into whole integers. And I believe because we're doing that, like, that's not going to undo itself properly. Essentially, I probably can't explain it in terms that are mathematically accurate, but basically, when we rotate one way, certain parts get rounded off, and when we rotate the other way, we're not rounding back. We're not rounding to the nearest, I don't think, or at one point I think we are actually rounding to the nearest, but the point is that it's still a truncate. Some parts of the math are still a truncate, so we're truncating both ways instead of doing like positive one way and negative the other way or something. But yeah, pretty good. Better than I expected, honestly. This is probably closer to what I expected. The 0.1 actually landing. Let's see how far you can go. And I think it will depend on your input image, honestly. So certain, like, different images probably would be, you could use different values and get away with it. But, and so then, like, if you wanted to achieve arbitrary rotations over time, like, let's say you wanted to make asteroids, for instance, and you want your ship to be able to rotate, if that's a thing you're trying to do, the way I would recommend to do it, I think, is not rotate the result. So not take your ship, rotate it once, and then rotate it again to a new angle. Not do that, but instead have your ship rotate it once to whatever angle you want, and then whenever you're ready to change angles, you start with that base one again. You take that base unrotated one and you rotate it again to the new angle, and then you update whichever one is showing to be the new one. With the current code, that's going to end up creating new bitmaps every time you call shear rotate, but I do think it would be good to add an existing bitmap argument here that's optional, and if you do provide it, then it will use that bitmap instead of creating a new one. Then you would be able to say shear rotate on your original, not on the output of your previous operation like this code is doing, but instead on the original. But you could pass in that bitmap as going to be reused, so you would at least not be needing to allocate a whole new bitmap. And your output would not be growing, because the other problem, if you keep shear rotating, the way the algorithm works now at least, if you keep calling shear rotate compoundingly, I'll say, if you call it on the result of a previous call, your new image is always going to be getting bigger and bigger and bigger and bigger. It's going to be transparent. The visible part is not going to be bigger. So everything will visually look the same, but there's more transparent pixels out here. And each time you call it, you're going to be getting a few more pixels on all sides. Whereas if you always call it on the original unrotated one, then you'll always end up with a rotated one of the same size. Whatever size it comes out to, you'll always get one of that size. It will never get bigger or smaller. It's really cool watching you figure out the math for it. Floats and rounding for rotation and shearing isn't going to be an easy problem. Hard display problems, which is why I love to watch you, or which is why I watch you. I'm sure whatever you settle on will be good enough. Yeah. I mean, this one's just an option too. Like, RotoZoom does still exist, and I think RotoZoom does have its places as well. This one just offers that unique property of basically pixel in, pixel out. Every single pixel that goes in will come out as a single pixel as well. Pretty close. So at 0.5, which is, what is the actual angle on that? That's got to be something like 20 degrees or... Oh, 8.5 degrees. Okay. At 8.5 degrees, we do get distorted a little bit. Two little chunks basically get distorted at 8.5 degrees. Eight and a half, for what it's worth, on this particular image also leads to this kind of weirdness where that juts out the side and then this juts out the side further, but... and the gap down here. But that's part of the thing where, like, with RotoZoom, there might not be a gap here because it could invent a couple extra pink pixels for us. And this one over here might be gone or something, but... let's try a couple more. So 0.5 I did. Let's look at 2.5. I'm curious to see how a couple of them look. I'd like to see a display IO example simple test showing RotoZoom examples next to sharing examples could help someone figure out. Yeah, that's true. Would be. Oh wow, look at that. So I guess that's the thing is, like, there are some that are gonna just coincidentally work, which is kind of wild. So, I mean, yeah, it's basically a roll of the dice, like how the truncations work out. Like, if your numbers work out to where your truncations are equal, then you'll come out equal. Interesting. I wonder if we could, like, is there a set of known angles? Like, could I iterate through all the angles and find the ones that do work. That might be interesting, so that you would know. But I still, like, the growing problem is still a problem. Like, this one is an extra 2 pixels in each direction or whatever, so you will still have that problem, which means I think my real recommendation is, I think, remains to be, don't do it this way, and instead always just call your shear on your original unaltered bitmap. Let's try, what is 45? Let me try a 45 degrees, though, which I don't know. 7, 8. I wish these were a little bit nicer, huh? Looking more like an IP address. Not bad, actually, on the 45. Coming back, not as bad as I thought it would be. The orange got messed up there a little in the middle. It's kind of interesting. The 45 looks good. For a 16 by 16 pixel image? Yeah, that's really good, I think. I could, so I could do, so what am I doing now? I'm doing, so we have, the original one is, sprite sheet. Yeah, to your, okay, actually, and in my case, the original, so sprite sheet, so when I was doing Blinka, we had an entire sprite sheet. Now, though, we actually only have one sprite, so the variable that's called sprite sheet is actually the original unmodified bitmap. And to prove that, I'm going to go down here to my shear rotated one, and instead of shear rotate on rotated, we're going to call shear rotate on sprite sheet. And then I'm going to rerun this, and everything is going to work the exact same as it does right now. .0, got it. Okay, good. And then now I could roto zoom this one, and we'll be able to compare it like DigiDevin was talking about just a minute ago. So rotated, so roto zoom. Basically, we would just add the angle, and that is in radians, the same as ours, so I'll just copy that. I will go ahead and comment this. Basically, this ended up being, I was effectively using RotoZoom, like this code here is effectively using RotoZoom as blit, because it happens to also do a blit if you have angle on 0. We did end up with a different one of these, though. Should we change these? Maybe we should change these. Okay, so that's one problem with RotoZoom, is it does not do any resizing at all for you. If we gave it a bigger one, would it work? I don't think so, but let's try. So if rotated bitmap was... So we know that our shear rotation one ends up being 24 by 24. So let me just make this 24 by... Let me comment it, though, so that we can go back to the old one. Let's do 24, 24. And then source clip is going to be 16 still. But PX, YX, I'm pretty sure that's like the center within the destination. And I'm pretty sure then instead of 8, we would want to use half of the size. So technically we could maybe be saying... But I don't think that it's going to create pixels for us. Actually, it did. I need to move it down some, but it did. That's actually pretty cool, too. I didn't realize that would work that way. But you have to, like, you kind of have to handhold it, because you have to basically know the right size to create your output image. Or the other option you could do is, like, make one full-screen bitmap and be outputting into that, I suppose, but... Where's rotated tile grid? Let's do 18, and let's also Y6. No. So, yeah, I don't know exactly how to solve for this. Somehow we would need to solve for this. I'm pretty sure there is a way to do it, since these other 3 corners ended up working correctly. But I don't know the right way. Maybe I was wrong about PX? Should those actually be back to 8 only? But I feel like it would have been messed up more if that was the problem. Nope, actually that fixed it. Fair enough. Okay, so those should stay on 8. So that's the sprite sheet width over 2. Don't necessarily need to go down quite so far. I guess it's fine though, honestly. I'm just going to leave it. Would be interested in seeing the behavior difference for 16 versus 17. Yeah, that would be interesting too, yeah, so that it could be perfectly centered. So this does do a very good job of illustrating the difference here between the 45 degrees. And at first blush, I would say obviously this 45 degrees looks better, right? It looks cleaner. But the thing is, this has invented pixels. Our center is now across, which is 5 total pixels. Whereas here we've retained the 4 pixel center. So we've retained not only the 4 pixel center, but the, every pixel is retained as 1 by 1. Whereas in this one, there are some new pixels that have been created. And in this case, it's all new pixels because of the angles we chose. But there could be some pixels that would get deleted as well in some angles and some pictures. So this would actually probably be a really good illustration of like this kind of square image right here basically pretty much probably looks better with roto zoom, but you have to pre-calculate your size. Whereas something more like Blinka or Mario, where there are individual pixels that are important, like Blinka's eye, I think, is only 1 or 2 pixels. Mario's buttons, like we talked about before, are only 1 pixel. And so on those, where there are individual pixels that are super important, that convey certain details, those ones, the shear rotate shines a little bit better on. Okay, here's what I'm going to do for now. I'm going to drop this code quick and dirty into GitHub, push it so that it's somewhere other than my computer. I'm going to go ahead and update color box and code. That's the only things we've changed. So I'm just going to go ahead and grab those and paste them here so that I have the latest versions in my little quick backup there. And then I'm going to go and just dump this into GitHub in a little placeholder type thing. Shear rotation experiment. Multiple experiments. I'm gonna also just put the castle sprite sheet and the Mario and this other file, even though I think that other file is like halfway working, maybe. If that even, we'll see, I don't know. But I'm just gonna take all of it, dump it into this new repo. Let me git ignore with that. Branch main, okay, good. Add all the code. Actually, that's gonna be wrong. That's annoying. I might not be able to push right now, I guess. Really not, is not actually how I want to do it. Alright, again, bear with me while I do this over here. Okay, repo gist, read, workflow read, user. Repo, workflow, gist. Read org, read user. Read user.email. User.email. All right. Push 2 commits. All right, there we go. That's pushed in. CodePy is the code that works currently, and color box is the image that it's using currently. So if anyone's interested in trying that out, there's the code, 17 by 17. Let me download that, and I will do that when I come back to it. But I think for now, I am gonna head out. Let's download this so we have it for next time. Thank you for that, by the way. Appreciate that. I will, once I do get it rotated, I'll ping you with the results. Imagine it'll be a little more satisfying. Yeah, I think this one will probably come out a little bit better on its rotation because of the oddness. Will help it not be offset different on one side than the other for sure. All right, thank you to everyone for watching. Hope you all have a good rest of your day and a good weekend and all that. I will see you all next time.